So, hey everybody. Hello. Thank you. Okay. So, hi. My name is Phil. If you're curious, I'm originally from Brazil, but I live in Berlin, just 1 hour flight from here. And I just, like all of you, were here listening to Martin's talk just before. And I actually am happy with the topic I've chosen to talk to you guys today, which is really about not necessarily Scala, the language, but how we use Scala at SoundCloud, where I work at, in case you haven't realized by the uniform. So we've been using Scala for about, I was actually just answering discussion, depends on how you count, but from 3 to 5 years maybe. When I joined the company in 2011, there was already a project in Scala. It's something called Stitch. Is in our GitHub is an open source time series layer on top of Cassandra. And we've iterated in many different ways. There's various talks from people from SoundCloud on how we migrated our architecture from the old school Ruby on Rails application that we have to what we have now. And this talk is really about some ways in that using Scala has shaped our way of thinking about our systems itself. Not necessarily just Scala. We also use Clojure. We have used Haskell in the past. We don't use it anymore in production systems. But we have a lot of different languages. But I'd say the functional way of thinking about things really has shaped and has given us an interesting perspective on different things that we could be doing. So start, because I don't know, SoundCloud is kind of dependent on what kind of music you listen to. You may or may not be familiar with us. SoundCloud is a European company. We are the largest audio platform on earth. So if we count just pure audio, we are bigger in terms of content available than everybody else. And we have everything. We have from the sounds of bats having sex. Yes, we do have the sound of bats having sex. To Skrillex, which to me sounds exactly the same. But you know, as you can see there, there's like Foo Fighters, Fast Company, all sort of different things, podcasts. I think we have 150,000 podcasts on the platform, including Serial, which was one that was really famous last year. There's a lot of stuff. And I'm kind of a music nerd, so I like the fact that it has a lot of stuff. I like music. I like talk radio. But when I'm talking to engineers, I think the most interesting part of what we're doing at SoundCloud is not necessarily what is in there, but how much is in there and what's the dimensions of things. So to give you some rough numbers, we have about 11 hours of audio uploaded every minute. So if you stop for the rest of your life and try to listen to what's in there, you're probably not going to be able to listen to everything. And we hit about 300 million people every month, or they hit us. This is a fuzzy number because we decided not to talk about the number of registered users because that doesn't mean anything. We may have an account and never come back. You may use the site as an anonymous person. But this is actually the number of people we can track as individuals using the platform for various different things, from the person who has a band to somebody just wants to listen to a podcast or listen to music. So it's a lot of traffic, and there's a lot of processing because these audio files, they're coming from multiple different sources. Somebody in this room could be uploading a track to SoundCloud right now. And because the music industry is funny business, it goes straight to a pipeline of multiple different steps for rights cleaning and transcoding, everything from the fun stuff, which is what's the best codec to encode this, to the not so fun stuff was like, who has the right for this track in Italy and has this company person approved the use under these and these conditions. There's a lot going on. And over time, as I said, we grew as a Ruby on Rails massive application. We broke down into microservices. Again, there's plenty of material published by us on that topic. I think I am the first person to mention microservices. Martin mentioned reactive. Docker is probably going to be mentioned at some point by somebody, because I think these three things, you cannot have a conference in 2015 and not have these three themes. So I'm the microservices guy. But as we go to microservices, we experience, as I said, we experience various different things. And I would like, just for the purpose of this talk, so we're on the same page, when I say implementation, I mean code. I mean just actually the code you write. Excuse me. When I say design, I actually mean how your abstractions are laid in one code base. And when I say architecture, I actually mean how different systems talk to each other. I do not recommend you use these definitions outside of the context of this talk, but for now, they're simple enough, they're going to be useful for what you're going to talk about next. So, personal story time. How I got started with object-oriented programming. It was interesting, like a lot of you, not everybody, but a lot of you, I started very young. My dad is an engineer, and he decided that he would give me a computer, but he wouldn't give me whatever was available back in the day because he was afraid I was only going to play games and not do anything useful. So he decided to give me a computer that was 10 years old. You probably never heard of this computer. It's an Apple II clone. As I said, I'm Brazilian. In Brazil, we couldn't import computers until the 92 maybe. So we had to, just copy everything and just build our own computers. That's why you never heard of it. The Brazilian computer industry, anybody? Yeah, thought so. So my dad kind of pulled this troll on me, and he was like, I'm going to give you a computer. I was like, yes, finally. But instead, he gave me the manual. And the manual was like this. It's basic. It's vanilla Apple II basic. Then eventually you get into machine. I think this is also the advanced part of it. It's like peeks and pokes and all this kind of stuff. But that was good because actually I started writing code before I even had some place to run the code. And also when I finally got the computer, I had to record on tape, magnetic tapes, and the recorder was broken. So I actually had to type, every time I turned on the computer, I had to type everything again. So I got real good at basic, trust me, in typing. But then that was how I got started, and I was doing my own stuff. I started actually making some money out of it, but I wanted to learn how to get better. And back in the day, people pointed me, the internet was not necessarily as accessible as it is today. People pointed me to the work people do in the procedural space. So I've read books. If you're old enough to know this book, it has had different covers in different countries. It's about a structured analysis and design, which there's a lot of stuff, and this was industry grade back in the day, but mostly it's about breaking things into modules. So one interesting point is that research was way advanced on all that stuff. But that's where the industry was. I think each of these arrows have some symbolism that I forgot. I think if they're full, they mean out, or I don't know. But it's really about modules and how modules interact with each other. That was great, because all my code, back then I think I was already doing C. I started actually thinking about modules and breaking down things. And then when I started doing object-oriented programming, C++, Java, a little bit of Smalltalk, I actually got into the classic literature around this. Funny enough, this book is actually pretty much the same as, the same as this one. Just, I think the author needed some money, so he made it object-oriented and using UML, because that's the thing to do in the 90s. But then we have plenty of books in object-oriented design. There's lots of stuff you can read, and they teach you roughly how to model your system, how to think about things, how to decompose, how to break things down. I was like, that's cool, that's cool. I like it. Actually, I became a big fan of this whole area on thinking of how to break systems. My path was like being really, oh my God, what is this? To like, oh, happier, 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 because I felt always evolving. I was actually building better systems. I was able to maintain systems that as opposed to the ones I wrote at this stage. And then eventually, actually, my gateway drug was the last book here, A Theory of Objects by Luca Cadelli. Actually, all Luca Cadelli's work is really about types, but eventually it got me started with functional programming. And then, start reading a lot of papers and books. There weren't many books for the industry. They were mostly for academics and research. So, the Lambda papers, all this kind of stuff. I was like, cool, I think I got it. I think I understand what this functional thing is about. But now, how do I structure my programs around this? If I have 500 lines of code, if I have 1,000 lines of code, how do I structure code around this? Funny enough, the first thing I got was a book by Peter Seibel called Practical Common Lisp. I really recommend this book. I haven't done Common Lisp in a while, so I don't know how far away it's actually from the current standard, but it's really practical and awesome. But it wasn't so much about what kind of stuff, like how to break the design in our scale. It was mostly about the implementation. The Little Schema series is also pretty good. Real World Haskell was like, finally, a book with real world in it. Boom. And it's a great book, definitely recommended, but it's really about the coding, it's really about the implementation as well, which didn't necessarily help me when I was looking for. So eventually I was like, okay, I need the advanced stuff. Give me advanced, that's it. I'm going to sit down and get advanced stuff. And then I went to a crazy realm. So it's finally going to lambda calculus, types in programming language. Who has read this book? Who has told other people they have read this book but have not read this book? I've done the same with the follow-up book. I have it, it's on my shelf, never opened it. So there's all these interesting, very, very interesting concepts and things you can do, but these are fascinating things, but they're not helping me. I'm in the industry. I need to, if I'm going to use this functional programming thing, I need to understand what's the best way to slice these programs. So my journey was like a bit like this. And to be honest, there's a lot of back and forth. Because I haven't been studying a lot in the more type systems kind of side, I'm saying right now I'm kind of here again. I will try to get there to the end of the year and then probably follow again. It's insane. But that wasn't meant to happen. That's my conclusion over these years, that there isn't a lot out there about engineering in functional programming. There's a lot of research, a lot of academic material, all this kind of stuff, but not so much about engineering. How do we make this work in the industry in various different scenarios? And then I start thinking about what we could use, right? So I hope this is readable. Oh, it's pretty okay, I guess. So if you look at this, this is a really oversimplified and a bit exaggerated version of something we do at SoundCloud all the time. We just, a user wants to like a track. So you go on SoundCloud, you go to track, you press the like button. A process similar to this one will happen, where we need to figure out if that user exists. And what we're doing in the first kind of block is that we're going to a different internal web service that's going to return yes or no if the user exists. Then we go check if the track exists, and that's done in the local database. And then we kind of see if both exist, then we call the other system that does the likes. Again, very exaggerated, and obviously I'm trying to make a point, but there's a lot of stuff in here. And I don't mind as much having a lot of stuff, but what I mind is that when I look at this code, all I see is it's HTTP code, MySQL code, HTTP code again. Besides that one line of code, it's really hard to tell what this is about. What's this code? What's this doing? And the interesting thing is that we kind of know how to, even though this is I'd say, it's very common code in our code base as well, unfortunately. But also when we have people applying for jobs and we send them a code challenge, something you can do in like 2 hours, they send back their solution, which these days more and more is in Scala. This is what we get all the time. That is this kind of code. That's it's not awful, but it's just combining a lot of different things. And if that was in object-oriented an object-oriented setup, what I would do probably is extract these things into maybe private methods, maybe classes, maybe things. In functional programming, we have this thing called function composition. I think it's one of the few traits of functional programming that most communities would agree, yes, functional programming has this. It's like very uncontroversial. And we can actually start using these things a bit more, I find. I think that if we can actually get something that's a bit less coupled to the details, and you can, for example, pass in the functions to that class, and then the class does the job. So this guy receives a check if user exists, check if track exists, add like to track, 3 functions, and then use these functions here. So the actual code you have to write is probably the same or more or less. But there was an example just last week where we literally replaced something very similar to this that used to talk to a memcached cluster with a zookeeper cluster. And if it was the previous version of the code, we would have to go everywhere and change them because everything knew about zookeeper. Whereas in this version, everything's a bit more encapsulated. So that's good. That's code, right? This should be, if you've been around the functional programming literature for a while, this is probably trivial and obvious even. But then I was thinking, well, the first thing that's interesting is that I think from this, from my experience in this area, I conclude that functional programming is correlated with what I consider to be good code, or functional principles in general. Now, I say correlated because I think the same happens, for example, with tests and with having good types. And obviously a good type system, but just specifying types. I don't think they're necessarily caused by any of these things. I think there's something underlying, maybe it's just the way dependencies are managed, that make these things converge in what I consider to be reasonable code. But then, OK, that's coding. Can we go up one level? Can we talk about design? Is that applicable to design? Well, how would that work? So let's talk about what happens when you go in your browser and you press www.somecloud.com, enter. I won't bore you with a very long architecture diagram talking about CDNs and things that I barely understand. But I will show a very simplified version of what actually happens. So the user sends a request, a green arrow. There's a request validator, and then actually you call the feature. So say you want to do a like the example. You want to like a track. The first thing we need to do, because this request coming from the internet, is to clean it up. We cannot, if you've ever worked in a public-facing website, or hopefully if you've ever worked in anything, you know very well that you cannot trust inputs, especially from the public internet. So there's a lot of stuff we do with this request before sending it down to a service. We authenticate the user, we check rate limiting, we check which region that thing is coming from. We see if we have any patterns in our spam filter that maps that request. We do heaps of stuff. And because there's so much logic and so much conditional logic, this can grow insane. This could be really, really, really big. So after many, many iterations, especially when we're still on Rails, of 200 lines class files, just dealing with this many different possibilities, we started to think, OK, can we actually, is this a problem where we can decompose things again? Can we think about functions? I know that if these were objects, we could actually think about classes and small classes. And I'm pretty sure there's a pattern with this name, definitely maybe 5 different patterns doing the same thing with different names. But can we do that with functions? And that was one interesting point, because at this stage at SoundCloud, we didn't really have an official language. We kind of knew we wanted to be on the JVM. But we had a lot of closure. We still have a lot of JRuby. But there's one thing that made us more towards the Scala front. It's actually the work by the Twitter guys, especially Marius, who wrote this paper after, but who created this library called Finagle. And it's a library we use everywhere at SoundCloud right now. The 2 reasons we use this library, one is what we're going to talk about later, is the design of the library itself. But also because, to be honest, in that library, there's 10 years of experience in people trying to do exactly what we are doing. So you see there's a lot of error correction code that now we know that we should have. But that day at 3 a.m. when shit broke in production, we didn't know. So we use a lot of the knowledge already acquired by Twitter and Pinterest and Foursquare and other people who use this library. But the design is what it's interesting for this talk. And the design is really about 2 things. A service and a filter. And this is a simplified type signature for them. I hope it's readable. But service is just something type parameterized with request and response. It could be anything. It could be a HTTP request, HTTP response. And extends a function that takes a request and returns the future of the response. The future thing, I'm not going too deep into futures. But the future is really important. The future thing is really important here because everything we do, as much as we can, we try to do it in an asynchronous way. So at SoundCloud, we actually need we have profilers to know exactly what's going on in the machine, because to be honest, while you're coding, you don't know when these things are going to be executed, which turns out to be a good thing in our case. But anyway, so you have the filter. That's pretty much a function. It's just an abstraction over a function. And so you have the service, that's an abstraction over a function. And you have the filter, which has a bit more of a complicated signature, but pretty much it's the obvious way. There's the service and there's the filter. Everything passes through filters. Filters can be chained and hit the service. So this is interesting because it's not very different from, functional programming, object-oriented programming, whatever, but it's not very different from things like servlet filters or the rack. If you do Ruby, rack has middlewares that do something very similar to this. On the JVM and functional, but closures, forgot the name of the library, but it's exactly the same. Like you pass in, it's actually based on the Ruby one, so you pass in middlewares into that. But the interesting thing, the more we're talking to the Finagle community, is that they're actually using this to implement business rules. Whereas most people I know use this other stuff just for non-functional requirements. So this is an example from the paper, because I couldn't get anything too clean from our own code base. But if you look at this, these are filters. This is how we wire a service, right? There's a lot of filters, and then this is the service. So it records the time it took to handle something, collects JVM stats, parse the request, log the request, sanitize, and apply traffic control, do all this kind of stuff, which at this layer are business rules. If you're building an edge service, that's kind of what this edge service is about. And this is pretty much what we're doing now. We export metrics to do everything using these filters. And the way it has changed our code base is that instead of having this thing where we have the user hits this big blobby code, it becomes a package at some point because there's so much code you can't possibly put in one class. We acknowledge the fact that there are plenty of components into these things. Each of these stats is kind of isolated, or you can isolate them. And more, like just rate limiting is something that we have removed and added back at multiple different times. So, okay, that's great. But if I have to go to that big class and add it and try to find out of those 200, I don't know how many 100 lines of code, what is the line I have to change? It's going to be insane. If you acknowledge that these things exist, then you can do something a bit more like this, where, just like the example before, you just keep wiring them. And because they're just wired and they don't really depend on each other, you can move them in and out. So the interesting thing to me is that this is exactly the same as before when we're talking about function composition. The mechanics are a bit different, but the way you're thinking is the same. Like you break into small independent things, you wire them together. Just like with functions, when you extract functions, well, you break one big function into smaller functions, it makes it easier for you to test and to do other things. It's the same with these modules here. I can test a rate limiting service without having to have the whole system up and running. It's very useful in that sense. So much that this actually, I took this screenshot this morning, and I think this literally, I just went to IDEA, press Command N, and type filter. And there's a lot of stuff in there. There's like air brake stuff and monitoring stuff. But you're probably going to see one or other things that look like business rules related, because that's a lot of what we're doing now. We obviously use filters a lot to do exception handling, or cores if it's a web-facing service. Circuit breakers we implement with filters as well. But we also add a lot of business logic to them. And we think of them as small little functions that we compose to then form a service. So after our experience with this, I'd say that the same as with code, turns out that there's interesting correlation between good design and functional principles. Small functions compose stuff out of small functions, break the monolith. That's good, but well, since we are here, we have 3 levels. We try to do this with design. Can we go one level up? What happens if we try to think about this one level up? So I said SoundCloud started as a big Rails application. We still have the Rails application. We call it the mothership. We tried to rename it to the Death Star, but the founder who actually wrote most of the code wasn't too happy. So it's the mothership. Right now it serves very little traffic. It's not internet facing anymore. It's an internal service, but it's still there. Probably going to be deployed about 3 times a day, like we deploy various things many times a day. But similar to the problem we had before, I think a lot of went on here is that we had we had to acknowledge the fact that just because SoundCloud.com, actually it's called SoundCloud, the project on GitHub is called SoundCloud. Just because everything that we do happens to be in the same code base, that doesn't mean they actually belong together. So we have the playback control, we have our track page, we have our groups, integration with Facebook. They're all in the same code base, they're all in the same system, but they don't have to be on the same code base. They don't have to be on the same system. They could, but they don't have to. And one interesting thing that there's many different reasons for us to move away from the monolithic architecture. I'd say that, to be honest, the largest one, I mean, it's a Scala conference, too easy for me to say here, Rails sucks, let's go to the pub. But it's not, it wasn't really Rails, even though I particularly don't like the technology stack. But it's really the fact that it was one big shared code base that took forever to build because there's a lot of tests. We are pretty good at testing, so the build takes forever. And everything you need to change needs to be extremely carefully code reviewed, tested, manually deployed. If you just change the Facebook integration, Facebook released a new, I don't know, API, and you need to change just this one call from A to B, you have to go through this process. And for you, it took 10 minutes to do the change. It's going to take 2 weeks to go to production. Because, by the way, there's all other 150 people in the company are actually submitting codes at the same time, or pull request queues, or like every day there will be more than 10 open pull requests. We had to have somebody who was the pull request reviewer for the week, who wanted to kill himself after a week, but just going after these things. So look at that. It was obvious, but it should be obvious now, but the team of the talk, right? It's like, okay, can we apply function composition? In that case, a bit more complicated because in my head, services are more like object with state plus operations than functions, especially pure functions. But it's like, but I would argue that yes, we can, and that's what all people, everybody, all conferences, all books now are called microservices. Is when you try to break these things down into manageable units. If you're in the code level, those will be functions. If you are in the design level, they will be modules or whoever you want to model. I know some people prefer to use full-on classes, and others just use the namespace pretty much. In the architecture, I think that they actually, the evolution we've been through means that they are microservices. And one interesting thing about the microservices debate in that sense is that those calls are expensive, right? So if you load a page on SoundCloud now, you're probably going to be hitting about 20 services. So they are very expensive. But just like when I was with my Apple II clone back in the 80s, trying to write some code, doing actually even making a jump from A to B was expensive with the infrastructure I had. These days, depending on what you're using, and depending on what your problem, where your bottleneck actually is, having this kind of infrastructure doesn't add as much latency as you could think. At least that's being, I think the only 2 companies that don't, that I know work at at large internet scale that don't do this are Facebook and Etsy. They both use PHP, maybe that's related. They both invested a lot in making PHP work for them. But everybody else kind of realized that this is not too bad, this can work, and it's fine. So the interesting thing about trying to map microservices to functions, or to use the same metaphor in different levels, is that since forever, we at SoundCloud, we try to follow this thing from Heroku, which is called a 12-factor app. It's not really a manifesto, it's kind of a manifesto, it's very demanding. But it's a guide for you to build applications. To be honest, it's pretty much to build applications that run on Heroku. That's it. But it turns out that if you follow the guidelines you should do if you're deploying elsewhere and you follow the same guidelines, you're in pretty good shape. There's plenty of stuff in there. There's a 12factor.net, I think, the website. But there's one thing that's really interesting to me. That's how it really emphasizes stateless processes. If you think of it, this is a reality for Heroku because Heroku runs on Amazon. And first, Amazon will kill machines. They will. It happens to us all the time. And then Heroku also wants to be free to move machines around. Maybe you're a free user. They want to move you to a different availability zone where it's going to be cheaper for them to run or whatever. So you must build your service so that they can actually kill it without destroying your business. Well, guess what? When you have a data center and a lot of users, this happens to you all the time as well. Like somebody will have to move machines around, somebody will have to do maintenance work, and if they have to kill your application for that, you'll be in bad shape. But more than that, even if every single system you have a state, have a database, you really should be careful. So, who knows this website? Good. So this is a blog. It's called afi.com or .net.com. And it's somebody who is now paid for, but I think it was just out of a hobby. He just destroys databases. it's gonna be fun, right? But the last one was actually yesterday or 2 days ago was the Aerospike one, which it's interesting because I keep receiving marketing mail, I should not say spam, from them, and they say they claim 100% availability, which is what? But and then there was like a very thorough, and this person is amazing. He opens bugs for the specific projects and does various things. But the point here is that do not imagine that if you stack a MySQL to your service, yeah, that's it. That's all I have to do, and it's going to be good. Or worse, you could be in a case where I was once where I was running MongoDB on top of Amazon EBS. So MongoDB is known for losing data. Amazon EBS is known for losing data. You run one on top of the other. You might as well not save anything. It's a shared memory there, but turn off the machine, it will be insane. But yeah, so you really need to be careful of these things. It's not a free lunch, like people like to say. So if you have an architecture like this, we actually kind of had, in various of our iterations, kind of like this. The little disks represent databases. So we have databases everywhere. Everything had its own little database. We use shared databases, which in MySQL is lovely. You start learning a lot about how MySQL breaks if you use it in that model. But then gradually, this is actually more an observation of what has happened than a plan that we had. Kind of went like this. And obviously, I'll make the parallel with filters and services in the back. More and more, the systems we have that actually need data, track metadata, extremely important to us. That's our business pretty much. User information, groups, this kind of stuff. They sit in a microservice architecture. They tend to sit in the leaf nodes. And everything else is like composing information out of these various pieces of data. And what that means is that oftentimes, these systems don't need a database themselves. So running through an example, because I'm running out of time. Say we go to the 9-inch nails page. 9-inch nails, anybody? No, not good. Every now and then, this is the only example I use because I get some cheering every time I put it up. But you guys disappointed me. So 9-inch nails loads the page. What happens? Well, I can't tell you exactly what happens because that would be really, really complicated for me to explain to my boss. But an abstraction is that mostly you hit a service that renders a track page. And what the service does is, again, following the indication of the little disk represented database, all it does is talk to 2 other services. And then these 2 other services actually do talk to other services that those then have state. They have the database. Everything up the chain doesn't really have persistent state. Now, I have caching. They have caching. They use caching heavily. We also have a fairly sophisticated system with event sourcing. If you know what event sourcing is, they can actually they can have a copy of the state if they want. They're just not the main source for the main maintainers of that state. They only do this to optimize the process and to be a bit faster. So going back to the point, I think it turns out, given our experience and my observation, functional principles also correlate quite well with architecture. Not with everything, and not all functional principles, because I don't even know what are all functional principles. And I think if there's no 2 people here who would agree with the same subset of functional principles anyway. But I believe strongly that they do. And again, correlated. I really think that this is the real reason this happens is because there's something common to these 2 things, functional principles and architecture, and good architectures. And I'd say that we still lack a lot of material on these things in functional programming languages. A lot of literature is really, really object-heavy or just don't give a crap about what you're using, which can be a bit frustrating depending on what you're doing. Everything we do, actually, if you are using functional programming language, being Scala or something else, I encourage you strongly to just blog and write and talk about it, because and write a book about it. We don't have enough material at all. But while we're in the theme of the correlation, and before I run out of time, I'd say that the whole TLDR here for me is small functions with small combinators, which are the things that actually put them together to make something useful. All the way up is probably a very good strategy for most of our use cases. Obviously, going all the way down can also help. But I find it curious that we haven't been thinking a lot about actually applying these principles with exactly the same body of knowledge we have for functions all the way up to the architecture. So I finished just on time, I think. I'm good?
Could you please go back to the slide with with the graph of your microservices?
Wait. Is this? Oh. I will. So this one or the one
this
for?
one is fine. Okay. So look, since you're intermediate microservices, they don't have state, right?
Most of them don't. Some will, but most of them don't.
So the question is, why do you need them? It would be better to have them as a library.
That's a very good question.
So you don't have HTTP overhead and all this.
Yep. We actually do have them as a library. Well, what happens now is there's a shared library in our JVM applications within SoundCloud. Every time something like this happens, we first implement it in the library. And what we see, we have seen for these specific cases, is that more and more other libraries and systems that don't necessarily use the library have to build the same logic over and over and over. Then we promote it to a microservice. There's another interesting thing as well in having, this is my first experience having a corporate library. Release management is really painful. So if to get everybody to upgrade, especially we've done something around authentication, authorization of content in the library. And I literally had to run the building and call our New York office, say, we need to upgrade today because we found this bug that's actually breaching our contract with such and such person. So there's different drawbacks. But most times what we do is we implement in the library, and then we promote our service if we see that actually is so widespread and is a concept in itself that then gets used.
So it's like basically the point is you separate concerns with the release and so on. Like, if you need to fix a bug, you can fix it just in this one library and re-implement it.
It's kind of the old debate back from like component-based design. Okay. Like, should we just attach this? Should we have this as a separate service? There's advantages and disadvantages in both. I like the idea of starting with the lib because you can iterate quite fast as well. And as you see, that actually becomes a thing. People start talking about that as a separate submodule. Then you might consider moving it to a microservice or some form of other system.
Thank you.
Cheers. Any other questions? Good. OK. I'll be outside if you have more questions or just want to chat. Thank you.